Hi everyone. Today I'm going to be showing you how to do transformations with matrices using GeoGebra. So we'll start the calculator any minute now. Here it is. We have our Cartesian plane. Now the first thing I might do is I can either create a point with the instruction point. Now the instruction or the command point requires brackets, and then inside that brackets I have to give the input is a list of two coordinates. So the curly brackets are for a list, and so that gives me the point. I decided to call it point A. There's other ways we can do it as well. We could use the tool menu over here. We could select the point tool, and then we could click on the grid like that. And if I go back to the algebra view, you'll see that it's automatically put in here that B is at coordinate 3, 3. So however we do this is okay. I might just, or do I want to delete? Do I? I'll leave point A where it is, and then let's make that blue. Okay. Now what I really want to do this time is I want to have a vector that starts at the origin and goes to point A. And I might give this the name little v A, as in vector A. And the command for this one is the word vector. And then I could give it the origin, and then I could give it point A, or if I just give it point A, it defaults to using the origin as the tail of the vector. So there's my vector, and I've just used the notation little v A for the vector that finishes at point A. They're two distinct objects in GeoGebra. Now, let's create a rotation matrix. A rotation matrix, and we'll be a bit fancy here. We will use the little soft keyboard to find the Greek letter theta, and I'll just set that equal to 30 degrees. Now if I use the function menu, I can put a degree symbol so that the software knows I'm talking about angles in degrees, and it gives me a slider with sensible limits. So that's good. Now I want a matrix, and I'll give it a name. I'll use R for the rotation matrix. Now a matrix is a list, so curly brackets for a list. Because I want this to be a 2 by 2 matrix, I will need a list with 2 elements at the top, and then comma, and another list with 2 elements. So it's a list of 2 smaller lists. And each of the smaller lists is 2 elements, being the first row and the second row. So I'll go back to the start there, and I'll start to type in what I want. I want the cosine of my angle theta. Then when I move to there, I'll have negative sine of my angle theta. So that should be my first row. Moving into the second row, I would have the sine of angle theta, and the third row would be the cosine of angle theta. And that worked. I'm slightly surprised that I got it right the first time. So there's my matrix, 2 rows, 2 elements, and depending on the angle theta, the numbers change. And I seem to have a large number of decimal places. That's all right. Now what I want to do is rotate the vector. So I want a vector called A dashed, and that's totally up to me to name that stuff. And that's going to be a vector, and it's going to be created by, or calculated by, R multiplied by vector A. So there it is, a matrix R multiplied by the vector, which I named VA, produces a vector as a result. And there it is. There's that. Now what I really want is a point at the end of that, and I can do that. I can create a point called A dashed with the point command. Now remember, the point command requires a list of 2 objects or 2 things, so curly brackets for a list, comma to separate the 2 parts of it. Now what I want for the first bit, I want the x coordinate of vector A. And I can do that with the command X, and then bracket. X is a command, and I want the X coordinate of vector A dashed. And then I move across past the comma, and I want the Y coordinate, again brackets for the function. The Y in this context is a function. It's going to go and pull the value, just the number of the Y coordinate from vector A dashed. And there's my point. I might change that to red. So point A and the image of point A, the image is A dashed. I'll make the slider visible, and I can hide all that algebra behind there, just open it and close it as I wish. And if I change the angle, then the vector changes, the image vector changes, and so the point at the end of it changes. I can drag the original point anywhere I like. No, I can't. I can't drag it anywhere I like because I put it in there with a command and it's fixed in place. But that's okay. Now, that's a very simple example. A more complicated example would be something like this, where I've got 4 points, each with its own vector, and then I've rotated each of the 4 vectors and created a point at the end of them. But I think you get the idea. Thanks for watching.